Welcome to Next in Food Systems, hosted by Imperial Business Partners. My name is Maria Jeanson, and today we will be getting deeper into current challenges and opportunities in the food system, exploring three different areas together with our invited academics. These are not the only areas that Imperial College London works with. We have an extensive Centre for Translation, Nutrition and Food Research, which hosts researchers specializing in precision agriculture, health interventions, to economics of food, to rituals and food design. There are many areas that the college works with that intersect with the space. However, today we'll look at three specific areas around democratizing nutrition, greener food and supply chains, and holistic processing. We have invited three academics to share their perspective on the future of food, from personalized nutrition to intelligent food design. And we will begin with a short introduction from each of the academics. Following this, we will move into a roundtable discussion focusing on those three themes. The first academic presenting is Dr. Isabel Garcia Perez, who's a lecturer in Precision and Systems Medicine at the Faculty of Medicine, Department of Metabolism, Digestion, and Reproduction. Welcome, Isabel.
Hello. My research has demonstrated that the same food does not fit all, because different people metabolize the same food in highly individual ways. Moreover, we have developed a 5-minute urine test that can accurately tell us what a person has been eating, classifies the quality of the diet, and measures interpersonal variability in response to dietary advice. I'm currently applying this tool in the field of personalized precision nutrition for the prevention and management of non-communicable diseases. However, these tools and my research is useful for other sectors, such as the food and nutrition industry, the athletes and those operating in the sport nutrition sector, health policymakers and regulators, and of course, other researchers investigating cardiovascular disease, metabolic syndrome, obesity, and microbiota. Finally, I think there is a gap to be fulfilled by multidisciplinary scientific research and the food industry in order to democratize nutrition by giving everybody access to the tools they need to be the healthiest selves.
Thank you so much for that great introduction. Next will be Professor Maria Carambelades, who's a professor in mechanics of materials in the Department of Mechanical Engineering. She's also the head of the Soft Solids Research Group.
Thank you, Maria. So as Maria said, my group is called Soft Solids, and it specializes in measuring and modeling soft solids, and particularly foods, looking at the mechanical response as a function of their makeup and microstructure. So food is very important. Food matters. It's such an important part of our health, but it's also much more than that. It's we connected with personal experiences and important life events. So understanding and applying engineering principles to understand how this food behaves, whether it's in the mouth or the gastrointestinal tract, is going to lead to really fascinating and novel tools for designing new and healthier food products and experiences. My group also develops models for not just for human processing, but also how food interacts with machines and manufacturing equipment. And this is important as it can lead to understanding how these food structures form during the processing at the various length scales, and how these impact the bulk response of the food. And lastly, another aspect of food production, which is extremely important and we're looking at, is concerned with food packaging and its impact on plastic pollution. So my group is developing solutions towards new designs of food packaging, such that single-use packaging is avoided, and contributing towards the circular economy.
Fantastic. Thank you so much. A really wide space of research that you work with around food. So next is Dr. Ferit Guder. He's the senior lecturer in the Faculty of Engineering, Department of Bioengineering.
Thank you, Maria, for the introduction. So the modern food system, as perfect as it appears, it's incredibly inefficient in both environmental aspects and in some ways economics too. For example, food production is responsible for 26% of all greenhouse gas emissions, and yet we throw away a third of all food that we produce. And also the way we farmed hasn't really changed since the 70s or 60s or 70s. It's just that the tractors have gotten bigger, and we would like to change this. We would like to develop technologies in my lab, focusing on end-to-end monitoring of the food system, so that we can improve the way we produce food, as well as we manage our food across the entire supply chain. Of course, we combine our sensing technologies with data analytics methods to derive insights from the data that we collect, so that we can make interventions to improve the way we handle our food and we grow our food. So food producers, distributors, and farmers would particularly benefit from our research for increasing their environmental efficiency and also their profits.
So Isabel, what might we need to do to make food and better health essentially accessible for the many, and what could that mean for a wide range of disciplines?
Well, I think COVID has shown to everybody that healthcare expense and resources are unsustainable unless we focus more to prevention. So I do think it's going to be like a before and an after that is really going to affect the way people eat and the way people care about their health. So I think because one diet does not fit all, we need to give that information exactly. We need to tell people what do they need to eat to stay healthy. And they need to know it precisely, and they need to know it, for example, when they go to the supermarket, when they go to a restaurant, they need to incorporate that information in their life. And we need to make sure this is something it reaches to them in a price that they can afford. So that is even not going to be enough, because people may want to know what do they have to eat, but they're going to want to eat foods that are tasteful, not just healthy. So I think we need a major development in terms of multidisciplinary teams working together to develop digital tools and also design new devices that can capture all of this information in real time.
Can I add to what Isabel has just said?
Yeah, definitely. Go ahead.
So I think another aspect of the work that Isabel was mentioning, how can you also design food at the microstructural level such that it does deliver the nutrients that you want to give to people? And also, how do you make foods healthier? If you take the sugar out, the salt out, people might not like it, but you could actually make up for that by doing more interesting structures, microstructures, such that consumers still likes what they're eating, and they will keep on eating the healthier, reduced whatever fat or sugar food and so on. So I think engineering can also help with and collaborate with Isabel to have a sort of a systems approach for how to make healthier food accessible to everyone.
That's really interesting. So is that the kind of crunch of the crisps and the kind of sweetness of the...
Yeah, that's correct. Yes. Yeah. You can design, we look at, this is what engineers do, they look at the microstructural level, how are various engineering materials are used for structural applications, how are they made? And how does that help them to sustain the load that they will be subjected to in service? So the load here is the load from the teeth. As you're eating it, it breaks into little pieces, and those little pieces will start melting maybe, or they'll start exposing whatever pastants you have more intensely. So all that I think can be combined such that you can make a food structure which will make a food that people will like, but it would also be better for them in the long run.
Food, I think it has really two aspects. One is the nutrition aspect, meaning that what we eat needs to be nutritious. And the other aspect is really we need to make it accessible to the masses, so that anyone should be able to afford food. So reducing the cost of production and then making food I guess more cost effective is really quite important for making it available to everyone across the globe of the entire the food system. And I think this is a really good thing and good trend, and I think there is no stopping. I think it will continue, and businesses should definitely continue to invest in digital technologies, in my opinion. And not only that, it will allow them to collect data and then centralize it and then analyze it to, again, so that they can make improvements. But aside from that, I feel like they will also empower the consumers at a completely new level to and hopefully introduce transparency to the supply chain. Again, many foods that we buy, for example, if we go to a supermarket, they have ingredients that come from all over the world. So we don't really have access to the information at this moment. So I think digital tools will allow consumers to have access to this information at an entirely new level. But of course, it's not only the consumers, but also the food producers and distributors and so on. They will benefit massively from digital tools. And again, for example, in my lab, we really try to develop technologies that would interface nicely with digital technologies. And again, purely because I think that this digital revolution will slowly spread into the food industry. And once they see the benefits, I think there is no going back.
So we can really empower consumers that want to stay healthy in a healthy planet. I think I agree with Fira that that's where the future goes. However, there is something that really, really worries me is once we give so much information to people that it hopefully should be the right information, transparency, personalized, really what you need to know. But if we get all of that information just because people have that information, it's really gonna create a behavioral change. I think that's something we don't know at the moment. No, we have bracelets that tell us how many steps do we walk. Does make us to really walk more, longer time, make time for that. So I think a lot of behavioral research has to be done on this. Because maybe people also need certain nuggets or certain options that help them to change their habit, not just information.
Climate change is a major threat to our food supply. So what are interventions that could help us address this? And I think you have some work that you're doing in that area, Firat.
Yes, absolutely. Again, I think probably the first thing we should do is reduce waste. So, for example, my laboratory works. It develops spoilage sensors that essentially tell us, how fresh a food product is, and then this way we can manage that food differently depending on where in its lifetime the product is, extending its let's say shelf life or I guess the expiration period. So because again, 26% of greenhouse gases, they come from food, which means that if we throw away a third, we're basically dumping all these greenhouse gases that cause global warming into the environment for absolutely zero reason, because we didn't make any use of these products that we have just produced. So managing our waste through monitoring it carefully will hopefully lead to less waste, therefore less greenhouse gas emissions. Because our immediate goal is to get to zero emissions, not negative. First is zero, and this would be a good step forward in that aspect.
Sort of the idea of having a more holistic perspective of the full system, from agriculture to final end result. Maria, do you have any more thoughts on that side, more in connection to the kind of industrial processing side of food?
I think for environment problems, I think one of the biggest problems is the fact that a lot of food is packaged in packaging which is not easily recyclable. And then this leads to, if it escapes to the natural environment, it could be quite bad for our ecosystem. But even if it is collected, a lot of it often ends up in mixed waste streams, which basically means either it's landfill or incineration, and neither of those things are good. They're against the circular economy. And the reason why this is happening is because a lot of food packaging has been very cleverly designed such that you use a minimal amount of material to keep the contents as fresh as possible to reduce the food waste and so on, transportation costs for the lighter pack and so on. However, because a lot of this packaging is made out of different layers, so each layer has a particular function, so to keep the moisture out, for example, or oxygen, and so on. Because they're made out of different materials, it's extremely hard to recycle it afterwards. Actually, they don't get recycled. And if you go to look at the studies where they cleaned up Thames and they looked at all the rubbish what they picked up, a lot of it was this food and drink packaging. So we really need to act on that urgently. We need to, one, find new designs for packaging, like crisp packets, for example. How can you redesign them with the recyclability as a part of the constraint in the design process? Or if you're going to take the existing stuff, you need to find better ways of recycling. So for making new designs, you can look at the thing that I look in my group, is we look at how those different layers are adhered between themselves, because they're at the moment possibly they're over-engineered, they don't need to be adhered so much. And if you don't have them adhered everywhere, then you'll be able to separate them, or even when you shred it, they can come out and separate themselves. So it's much easier to recycle it. Or if you taking existing packs and you want to make useful materials out of it, the problem is that when you blend them together, when the different polymers are mixing, they're not miscible, and therefore they do not form a good composite material that you can then use on for interesting applications afterwards. So we're trying to build computational models that predict what the properties of this recycled material will be as a function of the adhesion between the different phases and so on.
So we want less packaging, less packaging, less packaging. But there is a reason why we have packaging, because without packaging, essentially, food goes bad a lot more quickly. So by reducing packaging, we're essentially creating another problem. So really, I think the emphasis should be on how to, like Maria outlined, how to re-engineer these packaging materials so that either we can recycle them more effectively, or replace them with other engineered materials that would, let's say, biodegrade, or at least have a less of an impact on the environment. So packaging, I think, is a very critical issue in food systems of today.
What can we really get from understanding more the fundamentals behind the structure of the food that we ingest in terms of why it becomes a better nutritional choice?
The manufacturing process is going to lead to a certain structure in the food. And I think it would be great if the industry had these design tools that they can use to predict what the structure of the food will be if you use this pressure, that temperature, for example, and so on. And this is something that can be done. Of course, if you look at the metal forming industry, the polymer processing industry, they've had these models for a long time. However, the challenges for the foods are much bigger, because foods are a lot more complex materials, they're biological materials, as they very complex physical chemical processes that are happening. So you need to have a big group of scientists to be able to bring these models to life, such that you can predict things. Why would you want these models? Is because you don't want to make the trial, and the pilot plan. All this stuff is very expensive. You want to have a pre-designed tool that you can sit on your computer and see what will happen if I change, I don't know, this force, for example, this pressure on the material. And that will make it a lot easier to design. Also, for a computational models, also allow you to decouple parameters very easily, whereas in the real industrial line, it might not be possible to change one variable at a time. Once you change one thing, the other things change with it as well. Once you make these structures and you understand, then obviously the way something breaks will be very much dependent on what its makeup is. What are the materials that are in that product, and in how is it structured? How do you say that? How is this material distributed in space? That's what the structure is. So, for example, foams, the very crispy, sort of extruded sort of materials are very popular. it's be good to understand why is it that the consumer likes these foams. And there's a lot of research behind that, you know, basically says that once the cells start breaking, because if you have a foam, you have a cell, then it will vibrate and emit a sound, and that, you know, makes the crispy perception, for example. So that's one aspect. If you take chocolate, you know, you eat it, the way it fragments in your mouth for the first bite, it will determine how quickly the bits in your mouth will melt, and how then the chocolate interacts with the other surfaces in your mouth. And all of these things impact on the consumer perception, you know, whether they like it or not. So you could play around with structures such that you could make healthier products, basically, through that process.
So you can trick the consumer into liking the product more than they would normally do, because it tastes like something that is more voluptuous or interesting in flavor.
Yeah, it's correct. And I think I've heard of cases where such changes were made by stealth, you know, so the consumer doesn't know that these things were made, or you could even publicize it and say, this is what I'm doing, and, you know, see what happens. Yeah.
So what would be your main contenders about that you would like to re-engineer that is not so good for consumers?
Well, I think if everything that is very healthy becomes tasting very, very, very nice, that people just want to eat that, will be amazing.
Yeah, I think it's a lot of, because of our very busy lifestyles. I mean, not now that everyone's working from home, but before COVID, everybody's on the go. You know, you're always, and you don't really have much time to cook and so on, and everybody grabs these snacks. So I think making healthier snacks, which are produced basically in the industry, would have a huge impact on people's diets.
So how do you believe that collaboration across industry and academia can allow us to work towards a better food system?
Through my collaborations with the food industry, you know, I'm impressed at how much know-how there is in the industry for their products scientifically, and definitely it's stuff only through collaboration, using their experience on this particular products and using our sort of more fundamental techniques, you know, for how you can model things, how you can measure things together. I think we can make a great, you know, moving forwards, you know, how we can design better foods for the public. And it's very much an area where it's very much interdisciplinary as well. So if industry is going to work with academics, for example, if you're going to make something healthier nutritionally, then you would need to collaborate maybe like with a center like ours, which combines scientists, engineers, and nutritionists, you know, our food center for nutrition translation. The business school, you know, the people, you know, that look at the economics of food, and, you know, how, what we were discussing earlier, how come is it that the expensive food is the best for you, and the cheaper food, you know, that is available for the masses is the least nutritionally good. So definitely our center is, it brings all these kinds of people together, policymakers as well, and together with the business, the industry, and their know-how for their particular product. That's the only way we can make a solution to move forward, basically.
And industry plays a huge role, either because I think together we get to have knowledge and also more resources, because normally industry has more resources than academia. And I think working together, we can really accelerate this process of democratizing nutrition, basically.
I think the collaboration is incredibly important for two reasons. One is that academics do not really know what some of the problems are. And you know, when the industry, you know, comes to us and says, look, we're having this issue, and then and we would like to solve it, we may not even be at all, you know, aware of these problems. However, once we know, these may be relatively easy problems to solve for us. So, and therefore, I think collaboration is quite important. And the other reason I think why collaboration is really important is because academia is kind of at the fringes of research, right? Like we do the cutting edge, the state of the art. And for these technologies that are invented to become widely available to everyone, this, the industrial input early on is incredibly critical, so that we already start working together and develop technologies in a manner that could get translated more easily. So and again, I think in order for any technology to go out there, a huge number of people must benefit from it, and earlier engagement with the stakeholders will definitely be an enabling factor for translation of technologies from the lab to the industry, and then hopefully after that to the consumers and the wider public.
What are really your hopes for the future of food? So if we look 5-10 years ahead, what do you want to see next?
I think in a summary, we have seen that all these one-size-fits-all food policy advice or dietary advice from the governments has failed already in stopping the global epidemics of obesity, diabetes, cardiovascular disease. So we have a challenging future, and I really hope understanding what individuals need, how they respond to their diet, what they need, and also which specific molecules that are in the foods are going to help them to stay healthy. I think it's key for the future. So I really hope in collaboration with the food industry, we can build, and the digitalization, we can build this great future for all of us.
I agree with what Isabel just said. It'd be nice if we had foods which are personalized for different people, different phenotypes or something like that. So it's basically so that everybody gets the nutrients that they do need. I would also like to see a bit more, as engineers, there's a lot of research on people working with doctors for mending hearts and hip replacements and stuff like this, and nobody is surprised by that anymore. But when you say as a mechanical engineer you work to model digestion, everybody gets a bit surprised. I don't see, and I'm really surprised by that, because if you do sort out the food problem, maybe you won't have so much cancer stuff to work with, and other sort of diet-related diseases. So it is something that you need the technology and the science, that you can collaborate together with nutritionists, such that you can understand this important, biological process, the digestion, basically, and how you get the nutrients from what it is that you're eating. Just because they're there on the pack, it doesn't mean that you're going to access them just because they're available. So it's the way that they break, they form, and flow in your gastrointestinal tract. And that's what will determine whether you will actually benefit from what it is that you have just ingested.
Food must be safe, accessible and sustainable. So anything, I think, that contributes to these three pillars will either emerge or stay around.
Hello, my name is Professor Gary Frost, and I lead the Centre for Translational and Food Research here at Imperial College. I hope you've enjoyed the discussion and debate by three of our leading scientists. I think this is a good example of scientists who brought their background, skills and knowledge to bear in the field of nutrition and have successfully pushed back the scientific boundaries of the topic. The Centre for Translational Nutrition and Food Research brings together the Imperial community into a powerful multidisciplinary team that has the ability to solve problems across the food chain, from the field to fork to policy. The partnership with industry is incredibly important to us at Imperial College, and this is particularly so in the field of nutrition, which relies on a large, complex chain of industries to deliver the food that we currently eat. We hope that you have enjoyed this short video and it has captured your imagination. If it has, please do get in contact with us. Once again, thank you for your time and listening to this video.